Hello guys, welcome back. Today we are going to design the foundation system, which is a matte or a type of foundation. Uh, Firstly, we need to take the same model which we had taken last time and run the analysis and design procedures. Then go to tables, analysis, results, and we get frame results and column forces. Just double click on it. We need to collect the data, that is axial force of dead load as well as for live load cases, and note them down. For the bottom story, just use the filter option and select the story one. Okay, then the load case we now require dead load only. Dead load. Okay, next the station we need at only ascending part, that is at 0 0 locations. So here we have the locations, the axial loads as well as the shear force. These are the columns. Totally there are 16 columns at the plan at the first story. So now the question arises, which is C1, C2, C3, C4, C5. Okay, here model, structural objects, story 1, columns C1. This is C1. The same way show C2. This is C2. Like the trend is like C1, C2, C3, C4, C5, C6, and so on. There are basically 16 columns here in the plan. Now here here it is C1, C2, C3, C4 till C16, which are whose spacing along x and along y is same, that is 6 meters. And according to the problem statement, we have a SBC of the soil as 300 kilonewton per meter square, and the allowable settlement for which we need to design is 1 centimeter, that is 10 mm. And this is subgrade modulus. Subgrade modulus is calculated by the ratio of SBC of the soil to that of allowable settlement. Here the SBC is found to be 300 kilonewton per meter square, and here we have allowable settlement as 1 centimeter. When we convert, and we'll get 3 into 10 raised to 4 kilonewton per meter cube as subgrade modulus. Here we are using design strip method in designing the footing. So the column strip width, which is passing through the center lines of the column, is provided with 0.25 times of L1 or L2, whichever is less. L1 L2 is the space along X, and L2 is a space along Y. Here in our case, here it is 18, and here also 18. So we take 18, and the strip width is 0.25 times of 18, that is it comes out to be 4.5 meters. 4.5 meters would not be feasible, so it is better to take a strip width of 4 meters. Now I have made a table making all the considering all the forces, that is column 1, which is of a dimension 500 into 500, and the dead load that is along minus z, that is in the downward direction, is 1850. Live load is 797.6, and the material grade is M40 and HYSD 500. Please make a note of these so that it will be helpful for design purpose. So we need to take care of this C6 and C7, which are of dimensions 600 into 600 into 600, and which is having a dead load 5414.9, live load of 2797, same as that of C7, that is 4977.2 and 2579.8. In the same way, we need to take care of C10 as well as C11. Both are of 600 into 600. Okay, rather all of these are of 500 into 500. And the material grade, that is M40. The column, the concrete grade which we use for column must be same as that of a concrete grade which we use for the footing design. So this part is done. Now we can go to save. Open the model. So in this safe we design the foundation systems, and the safe full form comes out to be slab analysis using finite element method. Therefore otherwise we can take a new model. See, firstly it asks for the design code. Here we are using we are designing as per IS 456 2000. Preferences, this is the design code IS 456 2000. Minimum cover as per IS 456, we it has been mentioned 50 mm cover for the foundation, and bar size found to be, we can give 20. Okay, rather all things will remain the same. Here we have the models for flat slab templates. These are templates for flat slab perimeter beams, two-way slab, base mat, combined footing, single ribbed waffle. We can use the base mat or blank directly input, but in this case we are using grid only method. Okay, we have now it's basically a grid spacing. We can prepare a grid spacing of any distance. Okay, so along x direction we will give a spacing of 1 meter, as well as same as of along y direction, and number of grid lines along x direction come out to be 19, because it starts with 0. So it's a span of 18 meters. When it starts with 0, we consider that, so we need to give one extra, that is we get a matter of 19 there. Okay, we can go check here grid data, add or modify show. So here it is, based on spacing at the S it would be 0. And then we got 18. That's it. Okay, because this is the foundation which we need to draw in safe. First, define materials we can modify or still we can add, that is M40. Okay, remember we had taken M40 for columns there. Weight 24, lesser elasticity, then here 40. Okay, add new property, that is HYSD 500. Rebar 77, FY is 275 to 287. Okay, after rebar is done. Okay, okay, done. This is assigning of the properties. Now define soil subgrade properties. This is soil 1, so modify, you can keep it as soil. When we calculate the soil subgrade modulus, that is 3000. Compression only. Okay, define load patterns, dead as well as live. Okay, define load cases, here both must be linear static. Define load combinations, add new combo. Combo 1 is for strength, linear add here, add live here. This is 1.5, 1.5. Strength, click strength, and then okay. Add a copy of a combo. Here we can go for service combinations. Here linear add, dead is 1, live is 1, and check all these parameters. Okay, these are the service combinations. Now after the definition is done, we need to define the column properties here. Add new properties. We have two types of columns, that is 500 cross 500, that is M40 rectangular, 500 cross 500. Okay, this is one type. Add a copy. This is 600 cross 600 cross 600. Okay, done. Now define slab properties. Add new property. This is for slab footing mat, you can name it as mat footing. Or you can keep it as mat. M40 grade slab, it must be around 800, thick plate. Okay, now what we need to do is draw, quick draw columns, same as that of it has same options as that of tabs. Everything remains the same. Here there are two options here, property below as well as property above. Here we have columns above the foundation, so below must be made none, whereas property above must be given the properties, and the height below is 0, it can be made 2 meters. Okay, for every 6 meters we need to place a columns. Okay, this is first 6. Okay, for every 6 meters. Okay, So the other two types of columns are 500, 600, which are the inner columns, that is here as well as here. Okay, go outside and just right click it. It goes, or press escape, it vanishes. Next, you need to draw the slab over it. So what we need to do is draw a rectangular slabs in the areas. So the slab and the property type is mat. So select this point and just drag it. Here we got a slab, but it is extended 2 meters from this point. So cross check it. From the outer part it is 2 meters. So select this, edit areas, expand or shrink areas. So 2000, that is 2000 millimeters plus 500 divided by 2, that is 250. 2250. Okay, so we have 2 meters out of it. Next, now assign the properties. Select assign slab data properties. Okay, it is a mat. Okay, then select assign support data. We need to apply the soil properties here. That is soil. Okay, here it shows plus sign. It shows that the property of soil is assigned. Now we have assigned. We need to change the rebar properties here. That is, just right click it. We get geometry, loads, design. Here the rebar material is define materials. So add new material, HYST 500 77 212. That's fine. Two 75 287. Okay, okay. Just again right click it, design, change this to HYST, then okay, okay, done. Then again assigning is done. Now we need to assign the loads at each individual point. So what we need to do is just right click it. So now we need to assign the loads manually. Okay, so right click at this point and you can see the details here: geometry, design, other things, loads. Here it is blank only because there are no loads assigned. So assign loads, force loads, okay, dead load. We need to take the data from here. There is C1 for the dead load. It is 1850. 1850. Okay, it is minus that 1850, and the dimensions, that is 500 comma 500. Okay, this is dead load. Okay, again assign load, force load, live. 797.6. 797.6. Live load. Okay, so here it shows load patterns dead as 1850 as well as live 797.6. Same way we need to apply each and every loads at every point. Okay, so I have assigned each and every load here. Here to see the loads we have an option dead. Okay, show loading values, 3D. Okay, it shows the dead load. Then otherwise we can take it to live load also. Then we need to draw the design strips. So we are defining the design strips, that is we have taken it as 4 meters, strip width 4.5. for feasibility we have taken it as 4 meters. So how to draw it? So draw design strips. Strip A, just take 4 meters along end, right width, start along right and left. Okay, this is, it must pass through the center of the column. So show snap options, we can either use edges, parallels, extensions, intersections. Okay, so it will give you a proper snapping characteristics. It shows the pink color. The pink color indicates that the design strip has been drawn. Then select okay, this is strip A. and we need to draw strip B. Okay, now the designing part is done. So after assigning each and every loads on particular column, then we can go to run. So before design preferences, check whether it is IS 456-2000 minimum cover and other things. Okay, and you can right click on column strips. Check whether the rebar material is HYSD or no. If it is not, please change it to HYSD. Okay, check whether these plus marks are there and check whether a mat is assigned or not. And after everything is complete, just go to run analysis. It will show the deformed shape for the dead load as well as for the live load. Then again go for run analysis and design. Now we need to check if you want to check the stresses for the load combinations or for particular load stresses, these are the component forces, maximum bending moment. You can get the forces, those are the resultant forces. You can get it for the combinations as well. Okay, then display, we can check the strip forces for the load combinations as well, for layer A and layer B. Apply. Okay, we can check. This is for layer A, that we can see the maximum bending moment. Here we can get it. Then now along layer B, same we can check for shear force also in layer A as well as in the layer B. Close. Then display, show slab design. Now it is a strip based. Okay, strip based. Now we need to check this first mode impose minimum forces along layer A as well as along layer B. It will show the reinforcement both at the top as well as at the bottom where you will get the reinforcement. So when we impose the minimum reinforcing as per IS 456, then we can see some changes happen. That is, there is an increase in the reinforcements. So after apply for both along A and B, close it. Now we need to check the punching shear design. Initially we need to check for punching shear design. Yes, you can see that the shear strength of the foundation must be more than that of a stresses acting on it. If the value exceeds 1, it's considered that the footing is failing in punching shear. Hence, to prevent it from punching failure, we need to increase the thickness of the footing. Initially, we had given 800, so slightly we can increase it to 1000 mm. Okay, again run, display, show conjunction design. Here the inner columns are again filling at this inner part. So it's an iterative process. We need to increase the thickness. Can increase it to 1200. See, it is passed. All the values are well within the ratio, that is 1, well within the value 1, hence it is passing. Then display, you can see the crack widths for the load case, which is seen at the bottom. It is in the range of 10 raised to minus 3, that is 0.083. Hence the permissible value is 0.2 mm, hence it is permissible according to ASPO 6. Then you can close it. This is for that, as well as you can also see for load combinations. That is for service. Apply 0.04, 0.19 is max, so it is permissible. Close. Then display, show tables. Here concrete design. Here check the concrete slab design 1 flexure as well as shear data. Okay, it shows all the combinations, the maximum force for which combination it is governing, and each and every design details is shown for flexural as well as shear data. If its status shows okay for all the load combinations as well as for all the columns, then the footing design is correct, that is flexure and shear. If the footing passes the punching shear criteria, then obviously the flexure as well as shear will pass. But to be on safer side, just go and check it. Okay, done. Now the main important part is the detailing. In run, we have a run detailing option. We need to check all these three, then okay. This is the detailing main plan, drawing component. These are the drawing lists, the page numbers, general notes, rebar shapes. You can see here the code. These are the codes for 14. We have curve as well as in B, A and B. So these are the codes representing the type of a member there, type of a reinforcement provided. Here are the curtailment rules for top bars, 0.25 times of ln, exterior plan, interior plan, bottom bars. Okay. These are for column strips and these are for mid strips. And now the slab view, that is framing plan. This is the framing plan, and you can see the section along this line and section along this line. This is 1, this is 2. Okay, rebar table, bar schedule, bill of quantity, So here we have the rebar table based on the codes which I showed, and the number of diameters, how many numbers, what length, the total length, each and every detail is shown here. Rebar schedule, it is bar mark, bill of quantities. It gives the total weight of 44.64 metric tons. These are the individual slab view. Okay, this is the slab one. For the mat foundation, this is the rebar plan. If you check, read carefully the codes of those rebar shapes, we get to know these values. Top rebar plan, bottom rebar plan. These are just a plan of all bars. Reinforcement, what we are imposing, is all shown here. This is for top reinforcement. This is for bottom. These are the bottom reinforcement. Along section 1, this is the section detailing along section 1, and this is for section 2. Section 1, section 2, section 4. Profile, how much percentage of reinforcement, how much is provided. Okay. And along B, each and every data is shown here in the detailing option. Here we can, this is the sheets, list of drawings, general notes, can change the scale, as per the visibility you can change it, and if it is a legal version then you can go for printing also. Thank you.